All right, so to get started, I thought we'd do a little walkthrough of the site. I think most of you have probably seen the site already since you registered here, but I thought it'd be a nice opportunity to introduce each of the robots. So each of the robots you're going to look at here were created by JC and Robert, who are in the chat, so you can discuss anything or ask any questions about them that you have, but we'll just walk through. I refer to this robot quite a lot in the talk, and this is what we call the hero bot. This one is just playing around with a butterfly. He does briefly become confused when the butterfly flies behind him, but I do like it, it's nice. Scrolling down, we have the Gatsby bot, another good animation here, and we'll go into a little bit more detail about how we control these, but I did just want to point out some of the different states we have on these robots. So the animation for this robot is triggered by an intersection observer, so it doesn't play when it's off screen, but then when you scroll it into view, the animation starts. This was done on this particular robot because there is a part of the animation where it's out of the frame, and we didn't want folks scrolling to it when the robot was kind of off screen. I'll just keep going. We've got the Rive bot, which is super cool, and this is interactive. I don't know if you played around with this on the site, but if you move your mouse around, you can see that the head follows the mouse movements. Scrolling down a bit more, and we've got the form bot. Now this is hooked up to the form input. So for instance, if we attempt to enter an email address that's invalid, you get the form error as you normally would, but it throws the form bot animation into its error state. And then if you do enter a valid email address, we have a submitting state and a submitted state. So these are all triggered by Rive's state machines and inputs, and Guido's going to talk through and give a bit more information about how this was all created. But for me, I want to talk about the performance and how we added the robots to the site. So I'm going to jump over to my slides. We'll jump straight in here. So a bit of a backstory as to why we built Rise of the Robots, and mainly for me, it was to resurrect the past, which is a bit of an odd statement given that we're using bleeding edge up to the minute technology. But I liked the web from 20 years ago. I liked the creativity, and I liked how you could, particularly what I liked about the past was the character animations. And I'll talk a little bit more about Flash, but it's something that you don't often see on the web these days. We obviously have transitions and scroll animations and the like, but character animation was definitely something that's kind of dropped off. And I sort of wondered why, was it because visual creativity and performance are kind of at odds at one another? Is adding animations to your site going to negatively impact the performance? And I wanted to try and put something together where we could show that they can coexist in a performant way. And we're going to be covering a little bit about how to make animations accessible. And then lastly, we're just going to quickly cover the contentful CMS integration. So as I mentioned, it's flashback to 2002 when I used to be a Flash designer, and Flash designers were designers, developers, and ActionScript was the programming language you used, and we were also animators and illustrators, and sometimes actually were video editors and sound engineers. But sadly,
interaction designers.
Yes, there was so many. I mean, I think if you were a Flash designer, you were all of those things, and I think one of the reasons was because you couldn't collaborate on a .fla, which was the Flash file. This was kind of a locally saved file. It would be on your computer, and it's very difficult to actually work with someone else on that same file. If you did require any assistance or collaboration on it, you would have to send someone that file via email, and then obviously you end up in the nightmare situation of which one's the latest one and what changes were made. We didn't have diffs the way we do now with GitHub, etc. And there was also an element of, the concept of having a team to build a website was somewhat unheard of 20 years ago. The idea of a client or a brand spending, tens or hundreds of thousands of pounds to develop a website, it just wasn't a thing. And so one person doing it was pretty much all you had. And Flash websites were creative. I think probably some of the best examples of visual creativity on the web came from those Flash days, but performance really was important back then. And so to give you some idea of the connection speeds that we were talking about 20 years ago, dial-up modems were about 55 times slower than modern day 3G. Now, whilst broadband was kind of on the rise, it wasn't commonplace. And when we were developing Flash websites, we always had to be mindful of the fact that users could be coming from a 56K dial-up modem, and it was slow, very slow. So here's Flash. This is the Flash IDE, the integrated development environment. Apologies about the poor quality screenshot. It's quite difficult to find a screenshot of technology that hasn't been used for about 20 years, but it was great, and it did allow you to design and develop in one place. There was a bunch of tools that you could use to help illustrate characters, and the timeline at the top there, and you can see that sort of purple layer which has the arrows between it. They were keyframes of animation, and then the bits in between was the tween. And for anyone wondering, tween is short for in between, and that was the bit that Flash would work out for you. So animating from one property to another property, Flash would do the middle bit for you. And then a little bit further down, there was an actions panel, which is a bit like the console we have today in Chrome development tools. The output of a Flash file was called a SWIF. It was a small web file. This is very similar to what we have today with like a JavaScript bundle. And in the development mode, at least, you also had the bandwidth profiler, which today is very similar to what we have with Lighthouse. And it allowed you to dig in a little bit and see the overall file size, the frame rate, the strain it was putting on your CPU. Funnily enough, looking at the size of this Swift file, you can see the dimensions here are 600 by 400, which is tiny, but about the time, again, 20 years ago, the most common monitor size we were dealing with was 640 by 480, which is kind of the same size as a mobile phone in landscape mode today. So mobile first was definitely something we didn't call it, but it kind of was. And I think the same is probably true of the file weights that we were dealing with 20 years ago. This one's actually huge, thinking about it. 512K, that would have been a bad overall file weight for a Swift. But if we flash forward to now, and like I mentioned, I think some of the visual creativity, particularly character animation, has dropped off. And a lot of the websites that I see today are basically just text and images on a page. And I was wondering, can we do more with this? Is there a way to do it? Is animation really just a nice to have, or is it part of user experience? Is it a better user experience to have something?
By the way, Paul, just so you know, because I don't think you can see the chat, your message is resonating with people. Nathan said,
fantastic.
Yeah, drop an F in the chat to pay respects to the bygone Flash era. And
yeah, fantastic.
We've got a lot of those coming in.
Fantastic. Well, I mean, that's great to hear, because I think it is. I think animation is more than a nice to have. It can make up a good, in some cases, possibly a better user experience. But I think today, we're often very much focused on performance. And is that more important than creativity? So these are the things that we tried to address with this build. And so I wanted to provide some answers, maybe some examples of how you can perhaps win this battle when you're attempting to implement creativity in a modern day front end. I think with some of the techniques we're going to show throughout this project, I think we can demonstrate that you can have a coexistence between the two. I don't think website performance necessarily needs to suffer. And I'm going to show you how we did this with Rive. So here's Rive. And here's my statement of the day. Rive is better than Flash. And I'm not just saying that because I've got the Rive team on the webinar, but it really is. It's an integrated development environment. You can design and animate. There's the familiar looking timeline down there, which is, for those who've used Flash or perhaps After Effects, it's a very similar set of tools. But the big thing for me is that it's cloud-based. So there's no more of this having to have one file that you email around to work on. Everything's in browser. Designers can work collaboratively on this, and there's a great handoff between designer and developer. And this is the process that Rive and I use. And you can see where I've highlighted here, you can download for the newest runtime. And so once the Rive team had done their thing with the illustration and the animation, they just let me know. I download the Rive file and I implement that into my Gatsby project. But there were a couple of things I needed to investigate. And so whilst 66 kilobytes doesn't sound a lot. That is the cost of including Rive's React runtime in your project. Now, ironically, Gatsby and React is also weirdly 66 kilobytes. So in this project, I effectively doubled the size of the project just by adding Rive, but it's not the end of the world. Here's a typical implementation of using Rive's React canvas, and then here's an import for the hero bot, the .rav file, and that is typically how you would return it in JSX. Under the hood, the Rive component will return an HTML canvas element and accepts all of the typical HTML attributes. Here's an example of using role and area label, but Zach, who is Rive's DevRel in the chat, wrote a great post recently about how to use area attributes for accessibility. So I don't know if someone wants to pop that into the chat. But yeah, that's your typical way to use a Rive file in React. And I'm going to now talk about some enhancements we can make. So this would be how you would normally do it. A JavaScript import for the file that I've just showed, and then just return it in JSX as you normally would. And I'm going to call this the greedy method. And the result of this, if you look at your network tab, is that everything, including all of the essential JavaScript and let's say the nice to have JavaScript, which is how Rive animations play, all happens on initial page load. And if you do it this way, unfortunately, it will potentially negatively impact your site's performance. But by using some built-in methods that React has, namely here the lazy import and the suspense component, you can kind of circumvent this somewhat. So number one here, I've just changed the import to a lazy import. And in number two, I use the suspense component from React, which accepts a fallback prop. In this case, I'm just showing like a little loading spinner. And then when the page is ready, that signals that you can return the children. And in this case, HeroBot is the child. And this is the effect it has on the network tab. So I put that red line in where you can see anything to the left of it is the essential JavaScript. And that's, you know, all the bits and pieces that make the site work. And then to the right of the line are the Rive animations. So these happen after the initial page load. And this kind of tricks Lighthouse into thinking that your page is performant. I mean, it is, if you think about it from a user's perspective. Everything that's essential will load very, very quickly. And then we sort of politely introduce the nice to have animations. And this is the difference between the greedy and the lazy options. Rather annoyingly, both are 100% on Lighthouse, and that's because we're using Gatsby. You get 100% pretty easily. But if we dig in a little bit deeper into the metrics, you can see that the time to interactive between the greedy and the lazy is different. But best of all, the total blocking time is nothing in the lazy mode. So to answer that question, you know, can performance and creativity coexist? I think they can, and I think you can add creativity and animations to your website without negatively impacting your site's performance. But there's more. We can do extra performance. So this is a custom hook that I built. This is to enable us to determine when to lazy load, not just dealing with how to lazy load. So starting from the top, number one, I just create a React state value. It's called isPerf, and then there's the setter, set isPerf, and then a use effect. I'm just running a couple of checks. So the first check is for navigator connection.save data. Now this is an experimental feature. In some browsers it doesn't work, some browsers it does. You'll have to check MDN to see the browser support for this. But it's typically enabled by users that want to have a smaller data usage on their device. So if it exists, or if the screen width is less than 768, I'm going to set this perf value to true, and otherwise I set it to false. And then in 3, I just return that state value. So for this hook, use perf loading, it's either going to return a Boolean value of true or false. And then putting it all together with the lazy load, and I'm going to call this the double delicious method. So it's kind of extra performant. So number one, create a constant to hold the result of the perf loading hook. So this will either be true or false. And in number two, I can use that Boolean value to determine what to return. So if I do want an extra performant load, I just return a static image. And this is from Gatsby plugin image, which will do image optimizations for you automatically. And if we're not overly worried about performance loading, then I jump into the suspense, which will lazy load the hero bot as before. And so this is the result you have. So on mobile, and I've put that in sort of speech marks, we're not 100% sure it's mobile. Even if it's a small screen width, it could still be a desktop. But let's just say, for mobile, we get 5 requests, and this is 97 kilobytes. And then on the sort of ramped up version, which will lazy load all of the robots, is a few more requests, so 11 requests at 134 kilobytes. Accessibility. So prefers reduced motion is something that you can tap into. It's an OS setting, and it also exists in the browser. And this is for folks with vestibular disorders who might experience dizziness or sickness with motion. And this is somewhat of a complicated area to get right, but from the research that I've done, animation doesn't always mean motion. Motion typically refers to properties that change along the X, Y, or in some cases Z axis. It might also refer to scale X or scale Y properties. From what I've seen, it doesn't refer to opacity changes or color changes. But in either case, I think it's important to observe user preferences. And this is how I did it. So this is another custom hook. I've used this in multiple places around the site, and it exists in each of the robots. And I'll just talk you through what it's doing, and then I'll talk you through how I've used it. So number one, same as before, just create a state value to hold either a true or false value. And then we check for a media query, prefers reduced motion. We need to determine whether this has or hasn't been enabled by the user. And I'm going to skip 3 and 4 just quickly and just jump to 5. This hook will return true or false, depending on if prefers reduced motion has been enabled or not. Number 4 is really just for development purposes, and I'll demonstrate this shortly, but you can trigger or simulate a prefers reduced motion setting in Chrome DevTools. And by adding an event listener to this hook, it means that this will fire every time that preference changes, which just allows me to develop and just to check that it's actually being used correctly in the way that I want it to. And here's a little example of how you can simulate this in your browser. So you can run command, and if you type prefers reduced motion, you can see HeroBot there is now in its accessible state with the blinking light on its head. And then if I disable it again, and then we go back to the full motion state. There's probably a number of ways you could do this, and it's very much dependent on the type of animations that you're using. But you can use a custom hook together with some state machines, and I'll talk about those shortly, to control your animations based on users' preferences. So these are the state machines in Rive, and I think Guido's going to dive in a little bit more about this. But they're a bit like multiple states. I can only really reference what we used to do with Flash, where you'd have go to and play or go to and stop. But the idea generally here is that you can have an animation, one file, but it can have different life cycles. It can have different animation states. This one we've called the input is limited. So if is limited is true, then in the case of HeroBot, we just get an animation that has a flashing light on its head. If is limited is untrue or false, then it can just be in its full animation state. And there's an example, just a little code snippet of how I access the state machines. Use state machine input is a hook provided by Rive. And then I just wrap that up in a normal React use effect that will fire depending on the value of the prefers reduced motion hook. And as I mentioned, if there's an event listener here that will trigger this re-render every time that value changes. And then I can just set the is limited values to either true or false, which in turn controls the animation state of the robot. And then lastly, contentful. So invariably on any client build, you're probably going to want to have some kind of CMS integration. You don't want to hard code values directly into your code base. This was particularly helpful for me on this project as well. My team, Lacey, and a number of others were able to update parts of the messaging on the site, and we never really had to collaborate. I never had to make any code changes to ensure that the messaging was updated. And Gatsby has a number of ways to do this. The easiest way is to use some of our source plugins, which are quick to install and set up. But most crucially, you don't need any API knowledge to do this. And I think this is particularly important on a build like this, where my focus wasn't on pulling data from a CMS. That was, probably the least interesting part of this build. But luckily, with Gatsby source plugins, you don't need to worry about that. What it also will do, and I'll talk a little bit more about this, is to bake the CMS data into the page at build time. Normally, when you're talking about a connection with a CMS or an API, and this isn't always the case, but in some cases it would be a client-side request. With Gatsby, this is done at build time, which has the effect of actual content being baked right into the HTML page. So here's an example of what the contentful UI looks like. This would be typically used by, the marketers, the content creators. They don't have to dig around code to change messaging. You can just update some fields and then publish the changes when you're ready. And it's all in Contentful's rather snazzy looking UI. And then to install Gatsby source Contentful into your Gatsby site, it's a very few lines of code. A couple of API keys, and just resolve the npm package Gatsby source Contentful. Once that's hooked up in your Gatsby project, it will source all of the data from Contentful. So down the left-hand side in the Explorer, you can see all of the fields that are available to query. With Gatsby, you have our Graphical Explorer. And I know that GraphQL can be somewhat of a sticking point, but if you use the Graphical Explorer, you don't really need to write GraphQL. You can click around, as I've shown there in number 1. And in number 2, Graphical will create the query for you. And then if you press the play button, you can see in number 3, these are the returned values of that data. So this is the data that was stored in Contentful that we can now pull into the Gatsby site. And then number 4, again, you don't need to necessarily write any code. You can use the code exporter and just simply copy and paste the query, which you can then add into your JSX. And you see here, I'm using use static query from Gatsby, and this is just a GraphQL query that I've copied over from Graphical. And then, as you normally would in JSX, just return those values, and this at build time will, grab the actual values rather than the names and print it out in the HTML. And here's an example of what that would look like. I also wanted to highlight here, with JavaScript disabled in the browser, that text that was coming from Contentful is actually baked right into the HTML. So this isn't happening as a client-side request. This is all happening up front at build time. So again, it's another performance boost because there's nothing extra for the site to do once a user visits it. This is already in the HTML. And I'm not sure if this is necessarily the best way to think about this kind of stuff, but I often think, well, if this data exists in the page and without JavaScript enabled, it's very similar to how Google would crawl it and Google would see it. And so static sites are often better for SEO. I've added some links here. These slides will be available. I think we're going to say, if you want access to these slides after the talk, you can come and find me on Twitter. I'll pop my username in the chat shortly, and I can send you some links to these. And then we're going to jump out into a live demo. So there's a couple of things I wanted to just demonstrate: lazy loading, the performance loading, and the accessibility hook. So lazy loading. Let's have a look on the network tab. I've added a filter here, so I'm only concerned with files that are coming from gatsbyjs.com, which is the domain. If I run a refresh, yeah, here we go. You should see this is all of our essential JavaScript that makes the site work. And this is all of the nice to have JavaScript, like the JavaScript required to run the animations. And this kind of happens much later on. You can see it's sort of politely loaded, and hopefully down here you should be able to see there's the 11 requests, which include the lazy loaded JavaScript. And if I make my screen smaller than 768, which remember was the media query, just give that a refresh. And there we go. There's only 5 requests now. The result of this, and maybe I should move this. So here we have static images in place of the robots. So they're all static. They're all still there. They just don't animate. And then if I make it slightly larger and refresh, you can see there you go. These now load each of the robots and they animate. And I'll just quickly show the prefers reduced motion hook as well. So if I run this, you should see these animations have now all jumped into their accessible state. So blinking light on the head, Gatsby bot's having some work done over here, just a little blinking light on this one. And I think that just about wraps it up. Guido's going to take us through in more detail about how the animations were created and some of the cool things that you can do with Rive. So I'm going to hand over to you, Guido.
All right, thanks, Paul. I'm going to share my screen. Oh, before I get started, Lacey mentioned something in the chat, which has now disappeared since I started sharing my screen, but she wanted to remind everyone, if I remember correctly, to drop your questions in the Q&A tab, not the comments. If you want Paul and I to answer the questions live at the end of this, put them in the Q&A tab so that we can see them and put them on the screen when we answer them. Okay, so I'm Guido. I'm one of two co-founders of Rive. My co-founder is actually my twin brother. He's the engineer and I'm the designer, and that's relevant to what we're about to talk about here. And we came up with this idea for Rive, which is a design tool that helps designers build interactive graphics that are functional. They're actually ready to run. And we think that's important because of what Paul was talking about performance. When you are a designer and you're building content that is meant to actually run, whether it's on a website or on a mobile phone or in a game, it's important that you're aware of the performance impact of what you're building. Aside from also being just a better way, we think, to build graphics is to actually, not build a mock-up that needs to be converted or rebuilt at some point or a prototype, but actually build functional graphics like what you see here on our site. This was actually built in our editor. And so if I scroll down here, you'll see that Rive, the platform, is actually two products. One is the editor, which is where you design and animate and make things interactive. And we'll jump into it soon and show you how it all works. And the other part are the runtimes, which are libraries that allow you to load the files on pretty much any platform. And these are open source. They use standards across all their different formats. We have JavaScript, we have React, like Paul's been talking about. We have iOS, Android, React Native. We have a low-level C++ one that kind of is the guts of all of the runtimes, and it allows you to basically abstract a renderer on top of it and bring it anywhere. And yeah, that's basically the Rive platform and how it works. And if I jump into the editor here, I can show you how we actually built some of the stuff that we're looking at today. In fact, I'm going to start by showing you some files that we've built to demonstrate how Rive works. So if I jump into, this is typical file browser you've probably seen in a bunch of different design tools. But if I jump into like this rating animation here, you'll see that Rive, the editor, feels very familiar. This should feel like a lot of other design tools. You have a hierarchy here on the left. You have design tools. You can use a pen tool. You can draw a star. You can import graphics from other tools like SVGs, pings. We're soon adding PSD. So this is primarily started as a vector design tool, but we also support raster graphics. And then where Rive gets different from other screen design tools is we can switch to animate mode. You can either click up here or hit tab to switch between them. And you'll see that this should feel pretty familiar. Like Paul mentioned, Flash, After Effects, maybe if you've worked with anything with a timeline, this will feel pretty familiar to you. Difference is that everything in Rive kind of runs in real time. Nothing actually gets pre-rendered here. But this should feel pretty, familiar. You can expand things. You can see the properties that are being animated. You can select these and see their interpolation curves. Where Rive gets different from all the tools we've talked about so far is where you can actually start adding interactivity in. So we've got this concept of state machines, which if I make a new one here real quick, you'll see that it starts with a few default states, and you can drag and drop your animations in. You can create transitions between them. and you can set up certain rules for those transitions and control when they should actually interact. Now, I'm not going to show you this one because we have a functioning one over here. And I'm just going to hit play on it. And you'll see that it starts and it goes into this idle empty state. And when I start clicking around, you'll see that it plays the correct animation here. You can actually see what it's doing. Let me zoom in a bit, maybe so you can see it a little better. And you'll notice that we can interrupt this at any time. It's not like a movie that it's like jumping to the right frame or anything like that. It's actually mixing the states. And for how this is relevant to engineers, like if you're working with someone like Paul or Zach in the chat, is that you use what we call inputs in the state machine. And this is kind of that designer developer handoff that Paul was alluding to earlier, where I would tell Paul, hey, I built all the graphics. You don't need to know anything about how many stars there are, what color they are, what spacing in between them. All of that is handled by the designer. All what happens when I click on them is handled by the designer. All you need to know is that there's this input that we could have probably named better here. It's called number one. We could have probably called it rating or something, but you can change that. So you can change that to 3, or you can change it to 1, or you can change it to 5. And the graphics will respond. And the cool thing about this is that the designers remain in control of everything that is visual and interactive. And your developers just need to hook this up once. Once that's hooked up, you can change this graphic entirely. You can make it not be stars. You can make it be some other form of rating system. So this is a pretty straightforward example. We have another really simple one that's like this little toggle smiley. If I play this, you'll see that if I have this switch input and I turn it on, the toggle turns on. If I turn it off, it turns off. And you'll notice that there's actually some mixing going on between these states. So that if I spam it, it doesn't actually just jump to the right frame. It's actually mixing in between them. And there's a slightly smarter version here that actually starts at the right state without animating. But you can see that at the end, the engineer still has just a single toggle that's called, true or false. It's setting it true or false. But in this state, in this case, I've made a slightly more sophisticated state machine so that when I start it, it actually starts at the right spot. So you'll see that if it's on and I start it, it's turned on. And that's important because when you're loading your app, you don't want to see all your switches suddenly animate. You want them to be at the right spot. Whereas if you were using this one from before, you'll see that when it starts, it actually triggers an animation. Some other examples of things you can build in Rive are things like interactive downloaders. So this is something that would be pretty complicated to figure out how to build manually, and give your engineers like a bunch of motion guides to explain how to convert this all. So in this case, you'll see that as this starts, nothing's really happening. We expose 2 inputs on the state machine. One is called downloading, and it's a true or false, and the other one is progress. So, and there's also 3 layers to the state machine. So there's an indeterminate layer here. There's a water that's constantly animating. And I'll just stay on the indeterminate state here and show you what happens if we turn on downloading. So in our app, something gets clicked, or the button gets clicked. So it starts the downloading and it goes into this indeterminate state. And then as whatever you might be downloading, you're reporting to the file a 0 to 100 number for this progress. As that increases, you'll see that this water here starts increasing. And you'll see this is, I can drag it down, up and down. It's all like basically blending 2 animations together here. And when it goes over 100, it knows what to do. The state machine knows to go to a complete state. And I can also turn this back off and it'll reset itself. So you can see that you can build really functional graphics yourself as a designer, and you can be aware of the performance impact of what you're building because this all runs in real time. And you can also see the interactivity and actually test it out. So on that, actually, one really cool example to get a sense of animation mixing before we move into talking about the robots here. It's the last one I'll show. Oh, we also have bones. I'll show that a little better with the robots. Let me turn that off, actually, so they're not in the way here. So in this case, we have like kind of a start screen for an app or something where you need to set like a difficulty level. It could be a game. And you have this beginner state, intermediate, and expert. And you'll notice that as I click through these, it's blending at any moment. It doesn't actually need to wait for a certain animation to finish. So you'll see her foot can be halfway through when I click, or it can be all the way forward, and it actually blends those animations dynamically. I can also change the speed of this. So the mix speed right now is 300 milliseconds. You can set it to 5 seconds or 4 seconds. And you can see that now it's going a little slower. That's obviously way slower than what I want. So I'm going to bump it down to maybe 1 second. But you get a sense for how you can use your design tool to actually experiment with functionality. And provided this input that we have here, which is just level, we'll see if I change level to 0 or 1 or 2, it animates, provided that stays the same, I can change everything else about my graphics, all the buttons, all the colors, all the visuals, and it'll still work. So let's talk about the robots. The first one Paul was showing was HeroBot. You'll see that we're using multiple artboards here. So this just makes it kind of easier to be able to compartmentalize parts of the animation. So here we've got this, butterfly wing flapping. And go back over here. Here we've got the full scene put together with all the different parts. We've got bones in Rive, as mentioning, actually allow you to animate characters. This is all native to Rive, no plugins or anything like that. And it actually deforms shapes. So you'll see that when we start this, you get these really nice deformations on the character. You'll see like his hand animating, her hand, I'm not sure, their hand. And you can see that, yeah, you get these like really nice kind of depth and deformations, even on these tubes going on the back. They're actually connected to bones here so that as the head is rotating, they get this like nice sense of depth. You actually hide them so you can see them better. And the state machine has just one input here because this is our hero bot. So when it starts, let me deselect the bone here. When it starts, you'll see that it's just playing. We don't have any other inputs, but we do have this is limited state, which in this case, when we turn it on, it goes into the stopped state. But we have this other layer here where the light keeps playing. So the light animation keeps looping through. So there still is something happening. It's not just a completely static image. And then we can enable that again, and you'll see it goes back to idle and playing this loop. The next animation that we built with Paul was the Gatsby bot. And this one, we wanted to actually pause it while it was off the screen. So you'll notice that if I hit play on it, it starts playing, and it's actually right now in a paused state where it's not moving. My trackpad's not wanting to cooperate right now. And yeah, you can see that the is visible here is disabled. So if I enable is visible, it'll actually start playing its animation. And what's happening here is you'll see there's a few transitions in between these states. And if I select the right one here, you'll see that there's a condition on it saying that if visible is true, this transition should happen. It should go into the visible animation, and that's what's happening. And we also have the same input that we showed before, which is limited, where it goes into this limited state where there's some stuff still happening, a little bit of glows and fading opacities, but not a lot of movement. The Rive animation was actually one of my favorites. Where is that? I have it here, Rive bot. Here it is. So if we go over to the site, you'll see that this one actually interacts with your mouse. So if you're off it, you'll see that it's got this blue light. If you hover over it, it gets this little red light and starts tracking your mouse cursor. We built all of that functionality into the editor here, and then basically told Paul how to hook it up. So if you check this out, you'll see that there's a few different layers here to the state machine. And there's a few different inputs this time around. So if I play the state machine, you'll see that there still is limited. There's still, there's is limited, which stops the motion from happening. But then there's this extra state called is hovered, which if we activate it, that little red light gets activated, the animation changes a bit. And now we have these inputs that are called y-axis and x-axis, and they go from 0 to 100. And as I move that, you'll see that it's just basically blending an animation that sets a bunch of keys so that it's in one position. And then as I move to 100, it's blending to another animation where the head is all the way to the top and some other keys are moving around. I can do that with the x-axis too. You'll see it's going left to right. So when we handed off this file to Paul, we just told him, hey, you need to, when you mouse over, you need to set is hover to true, and you need to connect y-axis and x-axis to the mouse movement and just normalize between 0 to 100. And that's all that's happening here. When the mouse moves over, you'll see there it's at 100 x-axis. Over here, it's at 0 x-axis. Up here, it's at 100 y-axis, and down here, it's at 0 y-axis. All right, before we go into questions, I'm going to show you one last file, which is the newsletter bot. I want to make sure we have time for questions here. This one's probably the most complicated one. And I think the reason for showing it is that it does a good job of demonstrating just how nuts you can go with the graphics and with the state machines, yet still have all the same inputs. So in this case, you'll see that we have is limited, is pressed. There's another input here called states, which are the 1, 2, 3 states that the newsletter can be in. But our actual state machine is really complicated here. We have like this layer that has a bunch of different animations mixing together to make all the tentacles sync up. And at the end of the day, none of this matters to the engineer. This is all work that Paul didn't have to do. We didn't have to document how to connect all these different animations together, how to blend them together, what to do in certain cases. The designer, either Robert or JC, who are here to answer questions, has set this up. And all Paul needs to do is change this to, is pressed. In this case, nothing is happening because I think the state is different. There you go. And then I think there might be an error on 3. There it goes. But we just expose this info to Paul, and everything else the state machine handles on its own. All right, so that's a quick overview of Rive and what we did to build these robots. Definitely check out the Gatsby site to interact with them on the Rise of the Robot site, but also check out the link in Paul's slide deck, which will take you to a Rive page in our community that has all those robots available. You can click on these and you can open them directly in Rive yourself to see how they're all built, and yeah, play around with them. Over back to you, Lacey.
Awesome. Thank you both. There were a lot of questions coming in there. So Guido, I'll give you a second to maybe catch your breath after that, take a sip of water. We can jump in. And Paul, I know you were in the Q&A there answering some questions, so thanks for doing that, but we've got some more. So let's see, how are we on time? We've got about 10 minutes. We'll dive in. But just a quick note, and I'll remind everybody at the end too, if we don't get to all of the questions today, because there were a lot of really great ones, we're going to share Twitter handles, and we want you to connect with us on Twitter, and you can ask questions there. We'll just take our Q&A over there. So anyway, getting to it, I am going to start with you, Guido, if you're ready. You good?
Sure, let's do it.
Okay, great. So first question, someone said, that's really cool. I can use Rive on the web, sorry. Can I use it anywhere else?
Yeah, absolutely. So we have so on the web, we have actually 2 runtimes. We have kind of a high level runtime that makes it easy to use. There's a React component that you can just throw in. That's what Paul was using. But then we also have like a low level runtime that gives you a lot more access, and you can basically do whatever you want on it. And we kind of follow that model across a bunch of different platforms. We have iOS, we have Android, we have Flutter, we have React Native. There's a Tizen, Samsung built one for Tizen. There's a C++ low-level runtime that lets you basically take it anywhere and add your own renderer. The Google team actually did that. They're using it. They're using it in a few custom projects. So yeah, it's really, our goal is to get Rive anywhere. There's also game engine support coming in the future. We've been working on that for a while. So goal is to be able to create these graphics once and have them be able to run across all your platforms.
Awesome. Okay, good. I'm sure the person who asked that is excited to hear it.
And I'm sure I missed one of our runtimes, like a really important one, as I was listing those off, because we have that many.
Right? They're on the Rive website.
They are on the Rive website. You can go check it out. And they're also in our documentation. There's
Okay.
Go check out our website. There's a bunch of stuff there.
Yeah, you listed a lot. So probably if you want to use it on something, it's probably supported. But all right, Paul, you're up. Are you ready?
I am, yes.
Okay, excellent. Someone asked about which CMSs they can use, and what if there's not a source plugin for a CMS that they want to use to do something like this?
Yeah, great question. So if there's not a source plugin, you can integrate, well, basically you can integrate with any CMS database or API. If there's no source plugin, you can write the code yourself. I have got a blog post series which will walk you through how to interact with Gatsby's data layer. We do normally recommend you go for the plugin approach because it's just super quick, but you can do it all yourself. Incidentally, I will have a blog post coming up on the Contentful blog, hopefully this week, which will show you how to integrate with Contentful. And I made a short video from start to finish. It's 6 minutes. So that's how quickly you can accomplish this. But I will pop a link in the chat now to my Data Champion series, which will explain how to do all of this yourself.
Awesome. Cool. Thank you. All right. If you can't tell everyone, I'm just volleying back and forth here with the questions. So Guido, another question that came in, I think you did start to cover this, but this question was asked before that, but just in case, is there any limit on the state machine?
I guess depends on what they mean by limit, but no, there's, you can have unlimited number of states, unlimited number of layers to the states. Yeah, not that I can think of. You want to be aware as you're building things of the performance, which since Rive runs in real time, it'll make you aware while you're working on it if there's any performance issues. But as usual, test on different devices and that type of stuff to make sure that you're not adding too much complexity.
Okay. All right. Cool. Whoever asked that question, hopefully that settled it for you. But again, you can ask on Twitter if you have any follow-up questions on that. Paul, another question. Does using React Lazy Load reduce the amount of JavaScript downloaded?
No. So Lazy Load, yeah, so that's actually a good question. It doesn't change the amount of JavaScript that's being downloaded in total. It just changes when it happens. And so I think using a combination of Lazy Load and a number of other performance optimizations is kind of the sweet spot. I wouldn't say necessarily that Lazy Load is going to be the answer to all of your problems, since all of the JavaScript will eventually be downloaded. But it's that initial load is that what we're really focused on when we're looking at the performance metrics. And the reason for that is when you land on a website, you need your users to see all of the important stuff first. And this is typically, text or links to things. The less important stuff, animations, images, etc., they can happen a little bit later on. But that main bit, the bit that we need our users to see, the content, has to happen as soon as possible, and then lazy load everything else, and that'll just happen more politely.
Okay. Cool. Thanks. Guido, someone said, can I create custom animation component from scratch?
Yeah, that's a good question. You absolutely can. You can design directly in Rive, you can add animations in Rive, and you can add interactivity in Rive. There's no reason why you couldn't do it all directly in Rive, other than if you have a bunch of assets already built and you want to, import them into Rive, then you can export them as an SVG. That's the easiest way to do it from like a Figma or a Sketch or something like that. Export them as an SVG and then drag and drop them in, and you can start working on them from there.
Okay, cool. Thank you. The next one, let's see. Paul, is static content good for SEO? That's kind of a broader question, I guess.
Yes, I think in short, yeah, it's the best way to go with it. Yeah, I sort of touched on this when I was talking about, Gatsby's approach of baking data into the page. And so, yeah, typically when you're talking about interactions with an API, these are client-side requests. These will happen when the page loads and then JavaScript goes off and fetches data. Google doesn't necessarily see that data when it crawls it. And so static content, which is baked into the page at build time, is going to be there for Google to see, and you can see the effects on this when you disable JavaScript in the browser. If the content is there, then it's a lot more discoverable by search engines, and it's also faster for the page load as well. And so SEO doesn't always necessarily just relate to the content on the page. You know, Google has a number of ways to, aside the page ranking, you know, page load speed is important for SEO. Mobile optimize is also important for SEO. And I think with Gatsby, because we do so much of this up front in the build, what you actually end up with is just a fully complete, fast loading HTML page, which is good for a number of reasons. So yeah, static is always going to be better than, let's say, SSR. That's commonly known as the second best option for search engine optimization. SSG or DSG in Gatsby's case is definitely the most performant way to do it.
Great. Okay. I think this is actually a related question, but I also might be misunderstanding it. So tell me what you think. Someone else had asked, will this code be helpful in passing Web Vitals platform also?
Yeah, I think, yeah, a number of the techniques here are going to help towards all of that. And I don't think there's a kind of one way to achieve, those best results. And I think in a lot of cases, these smaller optimizations, and they are sometimes quite manual, but these smaller optimizations land in a big way when you add them up. So I think about these things as like, they're all 1%ers. So any little improvement you make to, a lazy loading JavaScript file or a lazy loading image or an optimized image, they all add up and they will perform better as a result.
Great. Okay. Guido, a couple of questions about exporting for you. So how are the animations exported and what type of files can the animations be exported to?
Okay. Is that so?
Well, there's one more kind of related. And how large is a Rive file compared to other formats? So however you want to answer.
Sure. So maybe that one first.
Okay.
If it kind of depends on what you want to do with it. If you're just using vector graphics, the file can be really tiny. A lot of the animations that you see on our website are just a couple kilobytes. Some of the more complex ones, depending on more states, more animations, more things moving, that's all a little bit of extra data that can add up. Some of them go up to like 20, 30K, but relatively small. If you add raster graphics to it, then of course that depends on how many layers and how many raster graphics you're adding. If you're importing pings versus JPEGs and that type of stuff. So typical best practices apply there. Make sure you compress your graphics before you import them into Rive, and that they are, you're thinking about that when you're creating your files. And then the other question on exporting. So we obviously export for interactivity first. That's the thing, that's the unique value prop of Rive. So we want you to export as the Rive format, which is binary. It's open source. It's we have it documented in our help center. There's some documentation there. I don't know that it's totally complete yet, but we've started documenting all of it. By the way, all the runtimes are open source too. And it's just binary because it makes it really small. It's really efficient. And then you would use our libraries, our runtimes, to be able to interact with that binary file. And we have an API that lets you manipulate it. That said, we also recognize that the Rive format isn't available everywhere yet. Like, you can't just drag and drop a Rive file on Facebook or Twitter or TikTok. And so what you probably want to do there is export a video. And we do have a cloud render that in our export menu lets you render out a video. It lets you render out a ping sequence if you need to keep transparency. Mm-hmm. I believe we also support WebP now if you want to render a video with transparency as well. We have GIF. So we have a bunch of different formats there.
Options.
Yeah.
Great. Awesome. Well, thank you both. We, as suspected, we did not get through all the questions. So if everybody on all the teams wants to drop your Twitter handles now in the chat, because we're going to have to answer some of these questions afterwards, after we get off here today. Just a reminder to everyone that did join us today, thank you so much. Thank you for asking questions. Thanks for being in the chat. Thanks for dropping all the Fs for, pouring one out for a flash. Like, we're all in that together. So thank you. And we will be sending you this demo fully captioned later this week to the email you signed up with. And then also just a reminder that Gatsby has another webinar coming up on June 30th. Someone asked a question about third-party scripts, so you'll be excited to hear that. We're going to be focusing on that. We'll have builder.io here with us. So definitely sign up for that one, free, just like this one. You can ask questions live. And yeah, so thank you to the Rive team for being here in the chat, speaking on Twitter, in San Francisco in person, all of the things. Thank you so much. This was a really fun project to work on. You have a great team. Thank you, Paul, for coming up with the idea and making it happen. And thank you again to everybody that joined us.
Thanks, Lacey. Thanks, Paul, for setting this all up. It was awesome.
No worries. Thanks. It was a pleasure working with you all.
All right. We'll see you out on Twitter. Bye, everyone.
Bye, all.